demonstrations, but we'll go with it and maybe throw in some random numbers. All right, so if you remember when we are multiplying and dividing fractions, all right, just remember that with our fractions, we have, say, our numerator, that's our top one, numerator, and the bottom is always called the denominator. Okay? And denominator. I had to think about that one for a sec. All right? So the top is the number of parts, and this is the whole amount, right? Remember, if we wanted to write, so when we see this 1/2, it's essentially a shape cut into 2 pieces, right? So again, let me just draw this. There's my whole piece cut into 2 pieces. 1/2 would be one part of that colored in, right? Now a whole would be, both of these, essentially 2 over 2 would equal that whole, or one whole piece. Okay. Then we have ones that we would call, so this is your regular type of fraction, right, or proper fraction, where it's less than 1 whole. Then you have our impropers. Okay, so improper fraction would be something like 9 over 8. Okay. All right, whoever that is that just popped in, don't worry, we are recording this little bit and we're just doing a quick review of multiplying and dividing fractions and then into a tape measure. So again, improper means that the numerator is greater than the denominator, which also means, again, let's look at the denominator. So 1 whole piece, or 1 whole, is then cut into 8 pieces, right? There's 4 pieces. There's 8 pieces. So essentially what this 9 over 8 is saying, that I have 1 whole pizza plus, and again, guys, it's just for the sake of a quick review, 1 whole, so 8 over 8 plus 1 more. Okay, so essentially that could also be written as 1 whole and 1/8. Okay, that's your impropers. This is also then considered a mixed fraction, right? Mixed fraction, is wholes and parts, all right? And when we are multiplying and dividing, we have to do some fun stuff with that one, all right? So that being said, let's get into some simple multiplying. So for an easy one, and again, you may recognize it because I have used this one before. Let's see, we have, right, 1/2 times 2/3. If you remember when we were adding and subtracting fractions, remember we had to have the denominators the same, right? Because we couldn't add or subtract apples and oranges. It had to be all apples or all oranges. When it comes to multiplying and dividing, we don't have to worry about that. We can multiply apples and oranges, right? We don't have to worry. When it comes to multiplying and dividing, or rather, sorry, the multiplying, we are going to go just right across. All right, so in this case, 1 times 2 is 2. 2 times 3 is 6. But remember, that's not our final answer because that's 2 evens, so it can go down lower. Right? In fact, 2 will go into itself and into the denominator. 2 will go into itself once, and 2 will go into 6 3 times. All right, so that is what is called our lowest term. Lowest term. We can't get any lower than that. All right. So that one's fairly simple. Two regular or proper fractions multiplied by each other. Okay. Now what if I had a mixed fraction? Right? So again, remember with a whole and a part. So again, we'll go with this one. We'll go 1 1/2 times 2 1/4. All right, so the way that we can do this is we're going to change these mixed into improper fraction. Right? And remember, the way that we do that is we take the whole number, right? This one right there, the whole number, multiply it by the denominator, then add the numerator. All right? So essentially, 1 times 2 is 2, plus the 1 is 3. But we keep the denominator the same. And then we do the same thing to here, right? The whole times the denominator, then add the numerator. 2 times 4 is 8, plus 1 is 9. Keep the denominator the same. Right? Now, we just multiply across like we did up there. Right? So 3 times 9, right, we get 27. 2 times 4, we get 8. Remember, this is now considered an improper fraction. So the way that that's handled, right, essentially it's 27 divided by 8. And just for the sake of writing it out so you see everything. Okay. So now 8 goes into 27 3 times. 3 times 8 is 24. Right? We do our calculating there. Remember, that's our subtraction. 7 minus 4. We're left with a remainder of 3. Okay? So we've got everything in this answer here. So the 3 is going to be our whole. Okay, there's our whole number. The denominator, right, that we used here and put here, okay, that's going to stay the same. So essentially, it's going to end up down here. And then our remainder goes up top here. Okay? So essentially 3 3/8. So far, so good for everybody? How are we doing there? Tiana, how you doing with that?
I'm good.
So,
Thank you.
You're welcome. So far, so good. So that's multiplying so far, right? And we just sort of changed that over from our improper to our mixed. Okay, now what if I gave you, let's do one more. All right, how did you do with those, Bill? Not too shabs? Ooh, let me remind you with this one here. I'm still doing okay. Good. All right, I want to pull this one back into play. Times 1 3/4. Okay, so here I have a whole number times a whole number and a part, or a mixed fraction. Right? First thing I want to do is turn this mixed fraction into an improper. But then I also got to think about this too. Right? So what we're actually going to do, we're just going to drop a 1 underneath that 2. We're going to multiply the whole by the denominator and then add that numerator. So if I wrote that out again, we now have this. 2 over 1 times 1 times 4 is 4, plus 3, 5, 6, 7. 7, Alexa, stop. 7 over 4. And just like before, go right across. Just remember, always if you've got that whole number, just throw the 1 underneath it. Okay, so now we go 2 times 7, 14. 1 times 4 is 4. That's an improper fraction. So once again, it's like 14 divided by 4. All right? 14 divided by 4. All right, we get, oh shit, sorry. What do we get? I think it's 3. Let me double check. Yeah, 3.5. Okay, so 14, 4, 8, 12. That's our 2. Okay, so we then get, there's our whole. Do you guys like it with the color coding, by the way? The whole. Let me use a blue this time. The denominator. And use this one. And the numerator. Okay? So essentially, 14 over 4 ends up being 3 wholes. Right? Denominator stays the same. And 2. But again, that can go lower. Right? So 2 goes into itself once. 2 goes into 4 twice. All right? So not too bad for our multiplying. Okay, multiplying our fractions. Let's try a dividing. Okay, so with dividing, we essentially want to get to this point right here. And here's where we do that invert and multiply. Okay, so let me bring back to a couple of simple fractions. 1/2 divided by 1/4. Okay, now again, you could do the cross multiplication thing, but I always had a hard time remembering which one was going to, like when we did the cross multiplying, which one was going to stay numerator, which one was going to be the denominator. So I prefer to invert and multiply. And multiply. All right? Which means I am just going to take this 1/4 and flip it upside down. And because I've gone and flipped this upside down, I'm going to do the opposite of what's going on in here. So this is now going to read like this. 1/2 now multiplied by 4/1. And again, just like I said, we wanted to get to this. Now we can just go right across the board, right? To the point where we have 4/2. Again, an improper fraction, right? 2 goes into 4 2 times, and that's the whole. All right. So one other thing I'm going to show for the invert and multiply is when you come across a scenario where you can cancel out. And let me use this one here. So I started with mixed fractions. So it was 2.5 divided by 1 1/4. Okay, again, just for the sake of showing, you're going to multiply whole by denominator, add numerator. Multiply whole by denominator and add numerator. So it now will read as this. 2 times 2 is 4, 5 over 2. It's still reading as a divide because I'm just getting rid of these mixed. 1 times 4, 4, plus 1 is 5. Now over 4. Right? But again, I like to invert and multiply. So now again, I'm going to read as 5/2. Now that changes to multiply 4/5. And here's what I mean by we're into a cancel out situation. When we get to this multiplication part, and it would even come into play in our regular multiplying. If we have a numerator and a denominator the same value, see how it's 5 to 5, right, in this multiplication. This actually cancels itself out so that it ends up just reading as 4/2, right? And then we break that down just as is. Improper, again, it becomes that whole number of 2, right? So, like I said, when you have these cross multiply here, right? Numerator, denominator the same, they just cancel each other out. The leftover numbers, numerator, denominator, become the answer. Bring it down to its lowest term. All right. That was sort of a quick little review of our multiplying and dividing. I hope that helped some. All right. Something I do want to show and talk about is when we are multiplying and dividing and even adding and subtracting fractions. Sometimes it may be easier to put it into those decimal forms. All right. So let's just say we'll go back to the multiplying. Say I had, now we'll keep it simple, 1.5 times 2 1/3. So if I go back to that one, times 2/3. If I was to put this into my decimal form, remember what this is actually saying is 1 divided by 2 and 2 divided by 3. So if I want to throw that into a decimal, 1 divided by 2, we should get 0.5, right? 0.5. And 2 divided by 3 should get us 0.5 0.666 repeating. Now I could write that side by side, 0.6666 repeating, or I could set this up stacked like we would have multiplying and dividing fractions, or sorry, multiplying and dividing decimals. But if I was to leave this in my calculator right now and do it decimal wise, so I go 0.66666 times 0.5, it should give me 0.3333 repeating. Now, I want to put this back into something I can read on my tape measure, right? In, say, a fraction of an inch. Because I can't pull this out and find 0.3333 repeating on my tape. So, in order to find something I can read, I already mentioned this one that I got here is broken down to 16ths. Meaning within, and let me see if I can get this a little closer. Within 1 inch, okay, so say even between this 4 and this 5, that's 1 inch. If I counted up every single ticky between the 4 and the 5, I would have 16 of these tickies. It's like that shape that I showed you, 1 whole or 1 whole inch, and I've cut it into 16 pieces. All right? 1, 2, 3, 4, 5, 6, 7, 8. 8 happens to be at my halfway point, right? Which makes sense because 16 divided by 2 is 8. 9, 10, 11, 12, 13, 14, 15, and 16 is my whole. Right? So again, I want to find this 0.3333 repeating on my tape measure, something I can closely read. So, what I'm going to do is take this 0.333 and I'm going to multiply it by 16. Let me write this down here. 0.3333 repeating. I'm going to multiply it by 16 because that is the smallest ticky on my tape measure. Okay, so in my calculator I still have that. Times 16, I get 5.3. Well, that 0.3 isn't enough to change the 5, so essentially 5/16. Okay, 5/16. Right? It's just another way that you can do it. And again, if you are multiplying things, you're converting your fractions into decimals in order to calculate that way. Bringing it back into feet and inches, right, especially into your fractions, right, you want to multiply it by the smallest set of tickies you have on your tape measure. And again, the one that I have here is 16ths. If I wanted to do this by eighths, so 5/16, it's going to land somewhere, and if I'm going to say between the 3 and the 4, 5/16, so 1, 2, 3, 4, because I knew it was going to be close to the quarter, plus one more. So it's essentially a quarter plus. Or, I don't know if you guys remember me saying, the vernacular I would use on site would be a quarter heavy, right? A quarter heavy by the 16th there. A quarter plus a ticky. Okay, that's what you may hear them say, especially at the training center. Plus a ticky. Okay, so 1, 2, 3, 4, and 5/16. All right. Did everybody understand that one? If I wanted to find this in eighths, I could have also done that. It won't be as accurate, but let's see. 0.33333, and I'm going to multiply it by eighths times eighths. It would give me, it says 2.6, but that 6 can bump that up to a 3. So essentially, it would be then 3/8. And if I look on my tape measure here, again, if I look between, say, the 3 and the 4, there was our 5/16, right? It was just past the quarter mark. A 3/8, 1, 2, 3 is just past the mark we had there. But do you see what I mean by you always want to try and get it the smallest amount? It's the most accurate. Right? And if I had gone by 30 seconds, even though this one doesn't show it, it essentially would have brought us somewhere down either into the quarter or just behind it. Does that make sense? When you have less than a whole inch. Hi, Edward.
Good evening. Hopefully you're fine.
I'm pretty all right. How are you doing?
I'm good.
Good.
Yeah, now actually this is whoever pointed out actually this topic here was just playing with my mind, because actually this is what I wanted also to go through. Still I haven't really understood like reading these like fractions on the tape measure. Now like you've been taking us through 5/16. In the first point, how do if I find such a fraction, like they tell me to read it on the tape measure, is maybe 3/8, maybe 5/16. Where do I start? Where is the starting point? Like, how do I tell that this is either in centimeters or in length inch? Where is the starting point?
Okay, so if I'm understanding correctly, Edward, you're wondering, are you asking, like, how do I know if I'm talking about inches? Is that what you're saying?
Yeah, when the reading is a fraction, now like 5/16.
Okay, so anytime, and it's more that, say, we're dealing with measurements, right? Dealing with measurements, if we see fractions, we automatically put it towards imperial. So feet, inches, and fractions. Right?
Yes, definitely.
Yeah, so in that case, I'm reading this part of my tape measure, the imperial, where you see your inches and that sort of thing. This tape that I have right here, this bottom half, this is metric. Ooh, and you remember when we said in metric, millimeters, 25.4 mils, or was it 2.54 centimeters is equal to 1 inch. Well, there's my 1 inch mark, and I know it's a little fuzzy on this camera a bit, but there's my 1 inch mark. If you guys were able to see in your tape measure, that 1 inch, if I go straight across, it is just ever so slightly heavier than 25 mils or 2.5. That's why we say the 2.54 or the 25.4 mils, right? But that's where you can see the conversion back and forth, right? And how it compares. But again, anytime that you have fractions, we're dealing with imperial measurements, right? Especially if someone's asking you to read something on a tape. If you're into these decimal inches, right? We can convert that into a fraction, something that we can then read. Like I said, if I want it down to the smallest increment, well, on this tape, I'm using my 16ths. Right. Does that help? Let me think. Let's see. I want to try and throw out another fraction that we can possibly read. All right. Well, I'm just going to throw this decimal number out just because I know it converts completely into something I can read. So this one here, if I had this number, 0.625, I can't read that on a tape, but I need to bring this into something I can do. And we'll call this a decimal inch. Okay. I need to turn this into something I can read on a tape measure. So I can either go by the smallest increments on my tape, which means I'm going to do this and multiply it by 16. I already know that this is going to have to be reduced down, but I'm choosing 16ths because it's the smallest tickies on my tape. 0.625 times 16, it gives me 10. 10 sixteenths, right, equals 10 sixteenths, but that's not its lowest terms, right? I already knew this one was a 5/8. Okay, 5/8 of an inch. Now I could have, because I already knew it, and I'm going to tell you guys a little trick. It doesn't work all the time, but I found the majority of times, not all the time, but quite frequently, that if a decimal inch, like we have here, if it ends in a 5, a lot of the times there's a good chance it's going to convert down to lowest terms in 8ths. All right. So a lot of times if I see 5 at the end of this, I'll automatically just times this by 8ths on my tape measure because I know I'm going to have to convert it down, right? So if I had done 0.625 and just multiplied it by 8, I will automatically now get 5/8. All right. Does that help at all? Edward, what do you think? Is that making sense?
Yeah. Conversion, everything makes sense. My point is just now, all right.
Good.
How do I read 5/8?
How do you read 5/8? Okay.
Yeah.
How do I read 5/8 on the tape? All right, cool. Let me see. Now again, some of this might be slightly fuzzy, and let me see if I can pull the autofocus. Nope, she ain't gonna change. Hold on. All right, I'll do my best to explain it. So, just for the sake of getting, I'm going to start here at the 10, just to treat it as a 0, just because it's hard when you can't see everything with this end piece. So treat the 10 as the 0. Then 11 is 1, 2, and so on. So 5/8. What this is saying, between this 1 inch here, all right, between this 1 inch, let's see if I can throw this here. 1, 2, 3, 4, 5, 6, 7, 8. Let's see if that works. All right, this is our halfway mark. There's another halfway and another halfway. So right now, I have this one split into, well, let me call that 0, and that's now 1 inch. I have this split into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So essentially this would be something over 8, right? I'm into 8 pieces. I could split this down, and now do you see how I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So essentially we are into 16ths. I could have also done here's my quarters. 1, 2, 3, 4. or my quarters. Okay. If I'm looking on my tape, all right, or actually, we'll use the little drawing I did there. So remember for our eighths. So I'm going to ignore the tiniest tickies and look for my stuff in eighths, which would be this one here, this one here, this one here, 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 and my final one. All right, 1, 2, 3, 4, 5, 6, 7, and 8. Edward, you wanted to find 5/8 on a tape measure. Well, we're going to count.
Yes.
Yeah? So I already know that 4/8 is actually 1/2. Or I can just count out. There's 1/8, 2/8 or 1/4, 3/8, 4/8 or 1/2, 5/8. Okay, which is this one here. So here's my, that one there would be, say, 1/4 or, oh, sorry. That was my 1/8. My bad. Sorry. There's my 1/8. Right here is my 2/8 or 1/4. There is my 3/8. Right? 1, 2, 3. There's my 1/2. Okay, I can call that 4/8 or 1/2. There's my 5. Okay, and so on down the line. If I look on my tape one more time there, Edward, let me go back up to the 10. Right? Again, this is in 16ths. Meaning there's 16 tickies that we are seeing visibly. 1, 2 16ths, which is also 1/8. 3 16ths, 4 16ths, right, or 2/8, right? 5 16ths, 6 16ths, or what do we got? 3/8, right? Do you see how they're different sizes? Does that help recognize it? A lot of time.
Yes, actually, Kelly, I think now I'm getting you right. Because I was looking at the starting point. So whichever fraction reading has to be like found within an inch space, like.
Yes.
Yeah.
Yes, it's within an inch space.
Right.
That's exactly it, Edward.
All right. Yeah. Actually, that's what I was looking at. But now you brought it out in details. Now, actually, I'm into it now.
Good. Yeah, a fraction is always going to be less than 1 inch, right? So if this is my inch right here, do you notice how I made different, I tried to do different colors, but I also tried to do different heights. Okay.
Yeah, definitely. I get 100% now.
Good. So the biggest one in the middle is always going to be your 1/2, right? Then your next splits or your next highest ones will be your quarter marks, right? This one's going to be at your 3/4 mark, right? And then you get into this next smallest one, that's into your eighths, right? So 1/8, 2/8, 3/8, 4, 5/8, 6, 7/8. All right, and then smaller even from there, the little green ones, those are your 16ths, right? So 1/16, 2, 3/16, 4, 5, and so on down the line. All right, so that helped you out, Edward. How about anybody else that might have been maybe tripping over the tape measure? And it's not uncommon, right? And you see there was more than one person that needed that extra little bit of help there. Okay. So Bill's doing good. Bill's doing better on that. Right? Tiana, how do you feel about that? I just want to check in with you.
I feel good. Thank you.
Yeah? Helps out a little bit more?
Yeah, it did.
Good, good. Something I'll give you guys a little hint, and I'm just going to pause this for a quick